Okay, going to run through a few questions from the exercises. I did warn you that logs were, a lot of people think they are the trickiest part of the higher course because they can be a little bit hard, some bits of them. But let's have a look anyway. Now, with this one, if you look at video 2, this is 1F. This one they hadn't, so it must apply, because they haven't given us a base, but they're all the same. Log quite often stands for log to the base 10, but it's irrelevant with this one, but you'll see why in a second. Okay? If I did log of 4 plus log of 6, remember it's the opposite rules to indices. So you know when you multiply indices, you add, when you multiply two terms, you add the indices. The opposite's true here with logs. When you add two logs, you multiply the inside of the logs. So it's the reverse of indices. So that is log of 4 times 6, okay, is 24. The other one, look, log a third plus an eighth. So that would be log of a third times an eighth is 1 over 24. Yeah? And if we add them, yeah, remember we're multiplying. You've got log of 24 times 1 over 24, which is just log of 1, isn't it? And if you remember, one of our other log rules was log of to any base of 1 is just 0. Because remember, anything to the power 0 is 1. So the opposite's true with logs, in that log of 1 is always 0, whatever the base is. Okay? So that would be the first one here. If we look at this second one, okay, they're asking us to solve an equation. First of all, look, we've got to combine this into one term. Remember, when we subtract, we divide. So, because it's the opposite, you know, with two terms, if one's divided by the other, then remember with indices, we would subtract. So it's the other way around. If we subtract logs, we divide. So it's going to be log to the base 4 of 3x minus 1 over x minus 1. See? Dividing by the x minus 1. That's equal to 1. Remember, to get rid of a log, we raise to the power, it's going to be 4 to the power 1. So what we've got there, 3x minus 1 over x minus 1 is going to be 4 to the power 1. Yeah? You basically turn that side into an exponential to get rid of this one. So it's 4 to the power 1, which is just 4, isn't it? So multiply by the bottom here, you've got 3x minus 1 equals 4. X minus 1 in a bracket. So you've got 3x minus 1 equals 4x, take away 4. Take that across there, you've got x. Take that across there, you've got 3. So x equals 3 would be that one. You need to make sure that you've had a look at the laws of logs, okay, which were in the video before you attempt these sorts of questions. Rather like the laws of indices, it's just something we have to learn to answer this sort of question. But just to remind you, remember what we said, if we're, first of all, to any base, I'll just call it A, of 1 is 0. Yes? Okay, we also knew when we add logs, okay, it's multiplying. When we subtract logs, it's dividing. When you multiply a log, I'll put B, log to the base A of x. Let's keep it general. Remember, inside the log, that is x to the power b. Okay, and remember, if y equals log to the base a of x, then x will be a to the power y. Yeah? So these were the rules that we're using to solve these. So you really need to make sure you've had a look at them, write them down next year when you're doing these sorts of questions, okay? You do need to remember them. I find the easy way is to say, well, it's the opposite of the rules of indices. Okay, so that would sort of cover a bit of video 2. In video 3, we had a look. You were given something like that, okay? And you're asked to write an expression. Okay. Now, remember, if you're adding 2, oh, sorry, you're asked to draw these, weren't you? Yeah? The standard log graph, if I draw axes, the standard log graph goes like this. It always goes through 1 on the x-axis. It will go through a1, a squared, 2, and so on. Yeah, so if they ask you for 3 points, you do those 3. That would be log to the base a of x. Okay? So here it's 2. So the graph, if it was just 2, yeah, if I change the colour here, then the graph would go through 2, 1. Now 2 squared is 4, isn't it? Yeah, so it would go through 4, 2. Okay, because when it's 2, the base is 2 there. Now we've done a few things with this. If we look at it, look, what we've done is the -1 in the bracket will shift it 1 to the right. So remember, that bit means it's going 1 to the right. Yeah? So you're moving 1 to the right, which means we're adding 1 to the x coordinate. And then after that, what we're doing is we're going up by 2. So we'll be adding 2 to the y coordinate. Okay, so that adds 1 to the x coordinate of your points. This adds, okay? So, what have we got? Well, let's change the colour of this. What shall I do? I'll do it in blue. No, I've done blue already. I'll do it in red then. Okay, if you looked at it, we were shifting it along 1. So that point would move to there, but then we're going up 2, aren't we? In fact, let's do it over here. So we're going to have our 3 points. If our graph looks like that, then our 3 points, remember we've shifted them across 1. Yeah, so that one, instead of being, that was 1, 0, it's going to become 1, 2, isn't it? Yes? This one, instead of being 2, 1, well, it's 1 further across, so it's 3 across, 2 more up would be 3, 3. This one 1 more across becomes 5, 2 more up would become 4. So that's where our points would be. I didn't shift that across 1, did I? Sorry. It should have been, that was 1, 0, so if we shift it across 1 and up 2, it becomes 2, 2, doesn't it? Because remember, each of these were going across 1, up 2. Okay? So, that's our graph. Let's find it roughly. That would be 1. You see how it's an asymptote to the y-axis there? It'll be an asymptote to x equals 1 there, okay? It will never cross x equals 1. So your graph would look something like that, okay? With those 3 points marked on it. Okay, remember, because that would approach there. We shift it across 1, it'll approach x equals 1. If we're asked to draw the graph of the next one, first thing I would do with this is you need to remember that's really minus log to the base 3 of x plus 3. So what does the minus on the outside mean? If you remember from functions, it means you reflect in the x-axis. Okay, so if we started off with our standard log graph, it's going to reflect in the x-axis. So it would look like that. Yeah? But then, so that's still 1, 0. But remember, we would have had a1, a squared, 2, a cubed, 3, and so on. So that's going to become still 1, but it's minus a. Yeah? And that would be, wrong way around. Yeah, no, it's a1, you fool. Sorry. Let's put in the numbers. That was 3. No, it isn't. What's the base? It is 3. 3, 1, because the base is 3. Yes? That one would be 9, 2, wouldn't it? So if we're reflecting in the x-axis, remember the y-coordinate becomes negative, so that would be 3 minus 1. That would be 9 minus 2. But then it says shift it up 3. So our 3 points, so that instead of being 1, 0, yeah, is going to become 1, 3. Okay. This point here, instead of 3 minus 1, remember we're shifting it up 3, that's going to become 2, isn't it? So you're going to have 3, 2. Okay, and instead of 9 minus 2, that's going to become 9, 1, because we've shifted it up by 3. So this, it's still... We haven't shifted it back along left or right, yeah? So it's still going to be asymptotic to the y-axis here, because it hasn't gone left or right, but it's going to look like that. It will eventually cross the axis. It's not asymptotic to the axis, yeah? Okay. The x-axis, but it's going to look something like that. That's where the 3 points would go to. Remember, these are all based on what we do with graphs of things, messing around with graphs of things, okay? If you remember back to your functions, plus starting off with the standard graph, which is this one, where it's doesn't cross the y-axis, but comes up there, goes through 1, 0, a1, a squared 2. That would be log to the base a of x. So it's putting those two things together, okay? They are not the easiest to draw, log graphs, but if they ask you for 3 points, if you get the general shape and the 3 points it goes through right, then you'll get the marks, but not easy to draw. Okay, the fourth video was asking you, where did I put my calculator? It's asking you about what are effectively exponential equations. I'm just getting my calculator. And you will be, for a lot of these, you'll be using a calculator. Now, the first half of this was when they give you and just say solve it. The second half is where they give you a really wordy question which does this, that, and the other, and you have to work out what you're going to do. Okay, I've written down the key information from question 5 there. That is question 4b. So let's have a little look at this one. Now, first of all, we want to get the exponential on one side and a number on the other. So I want to get rid of that. So if I divide by 0.2, I'm going to get e to the power 0.1t equals 5. Now, if you remember what I said, if it's e to the power, I would use this line button. You could use log, but it's easier to use the line button if it involves e. Okay, remember log stands on your calculator for log to the base 10. So what I'm going to do now, if I do line e, remember these two cancel each other out, just leaving you that bit there. So that would give me 0.1t equals, because remember line is log to the base e, and log to the base e of e to the power just gives you what the power was. That's why we use it. Right. However, I don't know what line 5 is, so if I do line 5, close brackets, equals, and it's about 1.61 will do. Okay, 1.61. Therefore, multiply both sides by 10, you've got 16.1. And that would be that one solved, okay? Remember, line just stands for log to the base of this special number e, which is a bit like pi, except it's round about 2.7. Okay? Okay, that's that one. Second one is also in terms of e. A lot of scientific things use e to the power. It's used for a lot of exponential functions. Okay. Now in this one, they said, it's populations of countries. That's your starting population in 2018. They told you t was the time in years afterwards. And they've asked me, first of all, what were the populations in 2020? Well, 2020 is just t equals 2, because 2020 is 2 years after 2018. So it's t equals 2. So I'm going to get, if you wanted m of 2, that's m naught, which is 254000, times e to the power 0.05 times 2, because look, 2 there. Yeah? If we work that out. Now, that's 254000 times, now e to the power, you just do shift and line. That does e to the power. So shift and line does e to the power. You can put it in like that if you like. 0.05 times 2. Well, you might put in 0.1 just to save a bit of time. Doesn't matter. That's what I've asked to work out. If I press equals e, that's horrible. Let's change that to, right, that's more like it. 280713. And I'd stop there because it's people. And you don't want bits of people. It tends to upset people. Right. Second one, you wanted r of 2. This time 371000 times e to the power. Now it's a minus here, minus. So its population is decreasing, isn't it? So again, we're going to do 371000 times shift line to get e to the power minus 0.02 times, I just hit 6, times 2, that's better, equals, and it gives us 356453 to the nearest person. Okay, so that's what we've got there. Second bit says, where are these two equal? Okay. Now, I'm going to put, so what we've got is we've got 254000 equals, times this thing, e to the power 0.05t equals 371000 e to the power, or times e to the power, minus 0.02t. Okay? Right, what I'm going to do is I'm going to divide by this. And remember, if I divide by that, in this bit, it'll be the same as adding the two bits together. So if I divide that by that, I'm going to get e to the 0.07t. Okay? And that's going to be equal to, I'm going to do 371,000 divided by 254,000. Okay? Because it's in E, I'm going to use line to get rid of E. So if you take line of both sides, I'll just get rid of the E there. Don't know why I'm putting all the zeros in. You can just cancel them out like that. Okay, so we've got that. So T is going to be line of 371 over 254 divided by 0.07. At this point, you definitely reach for your calculator. So line, fraction button, 371 over 254, close the brackets, and then divide it by 0.07. And if I do that, that tells me in 5.4 years, the populations of these countries are going to be the same. Okay, that's how we do those. These can be a bit tricky. I picked the hardest one to have a go at. Okay, these ones aren't too bad. If you remember, you need to use line if it's e to the power, or if it's not e to the power, use log to the base 10. Remember, I did show you some in the video like that. Last one was about logs, graphs again. Okay, if we look at this one, if it's log against log, okay, it's going to be x to the power. If it's log against not log, just ordinary, then it's going to be an exponential, like that one. But if we take this one first, if I do, now what we're dealing in, log to the base 9, let's do log to the base 9 of both sides. What we've got is log to the base 9 of y. Remember, when you multiply, you add, and when you raise to a power, you multiply. So I'm going to do it. So you're going to have n log to the base 9 of x plus log to the base 9 of k, because you multiplied by k, which is why it's added on. You raised to the power n, which is why it's multiplied. Okay, straight line graph. First of all, we need the gradient here. Well, look, it's gone across 1 and from a half to a sixth. So it's gone down 1/3, hasn't it? So its gradient will be minus a third. Okay? And its y-intercept is a half. That means that log to the base 9 of k is equal to a half. Okay? And the gradient is just the same as n. So it's minus a third. Okay. You wanted k. To get rid of a log, you raise to a power. So k will be 9 to the power a half. Remember, a half is the square root. Square root of 9 is 3. So the formula for this one was y equals 3x to the power minus a third. Okay. If we look to the next one here, remember what I said? This time, if you like, the t is the y and the n is the x here. So these are our variables, okay? Those are our variables. So it's a and b that we are trying to work out here. Okay, so if I did the log of both sides, what are we dealing with? Log to the base 10. Going to have to use a calculator in this one, I expect. Okay, and what have we got? If we do that, we're going to have n, which is our variable, log to the base 10. Okay, I'm taking the log of both sides here. Log to the base 10 of b plus log to the base 10 of a. Okay? So this time, that is the same as our gradient Well, look, it's gone up 1.2 for 2 across, so it's 0.6. Okay, that's our gradient. So we've got log to the base 10 of b equals 0.6. So b is 10 to the power 0.6. We also know where it crosses, so log to the base 10 of a is equal to 0.7. So a is going to be 10 to the power 0.7. Let's work these out on our calculator. Okay, we wanted shift log gives you 10 to the power. We wanted 0.6. That gives me 4.0 to two significant figures. What about this one? 0.7. So shift log 0.7 gives me 5.0 to two significant figures. So what we had here was t equals a was 5, so 5 times 4 to the power n. That's what our formula would look like. Okay, these are quite tricky, but if you remember, if it's log against log, then the gradient is our power, and we need to do raised to an exponential to find where it crosses the y-axis to find the multiplier. If it's an exponential graph, we've got like this one, it will be log against whatever the variable is. Normally it's log y against x, but in this case it was log t and n. But where it crosses the y-axis is still your the exponential of that is still your multiplier, so it's the same as this. But it's the other way around with this one. You need to do the exponential again to find out what b was. Okay? So that's the difference between the two. I know these are tricky, but just have a look at them and watch the videos. Bear in mind that this year there is going to be an optional bit in the exam. Well, they're planning to do an optional bit. We haven't sorted out what we're doing for exams, where you're going to do either the circles and exponentials and logs, or it was going to be recurrence and vectors. Okay, so if you find these really too difficult, don't worry about it too much. It's likely to be part of an optional bit. I hope that helps, but as I said, don't worry about these. Just have a go at them. Okay. Bye for now.